October 24th, 2025. In the quiet expanse of the South African desert, a cluster of 64 giant antennas turns its gaze toward the heavens. The MeerKAT radio telescope, one of the most advanced arrays on Earth, picks up a faint rhythmic pattern at 1665 and 1667 megahertz. At first it seems ordinary, just another signal buried in the endless sea of cosmic noise. But when scientists trace it back to its source, a name appears that instantly electrifies the astronomical world. 3I Atlas. For months, this interstellar visitor has been the subject of intense debate. Is it a comet, a fragment of an ancient world, or something far more mysterious, perhaps even technological in origin? But now, with this single detection, the mystery takes a dramatic new turn. The signal isn't the kind that carries messages or digital information. It's not a transmission like one might expect from an alien probe. Instead, it's the distinct fingerprint of hydroxyl radicals, molecules that whisper of ice, sunlight, and chemistry. What MeerKAT detected was not a message, but a signature, a natural one, etched into radio waves traveling across millions of miles of interstellar space. The scientists at the South African Radio Astronomy Observatory confirm it. Absorption lines, at exactly the frequencies associated with comets when they interact with solar radiation. This single detection, faint but undeniable, tells a story billions of years in the making. When a comet approaches a star, or in this case our sun, its frozen ices begin to sublimate. Water vapor is released into space, and sunlight breaks those molecules apart, forming hydroxyl radicals. These radicals then interact with sunlight and radio frequencies, creating patterns that astronomers can detect. That's what MeerKAT captured. It wasn't a message. It was evidence of life's raw ingredients reacting to heat and light. Still, for weeks before this discovery, the online world was buzzing with theories. Conspiracy channels, podcasts, and even celebrity talk shows speculated that 3I Atlas might be something artificial. After all, this is only the third known interstellar object ever observed entering our solar system, after Oumuamua in 2017 and Borisov in 2019, and both of those objects left scientists scratching their heads. So when 3I Atlas appeared, streaking toward the inner solar system, the comparisons were inevitable. Its shape, trajectory, and behavior seemed unpredictable. And when early telescopic data hinted at non-gravitational acceleration, movement that couldn't be fully explained by the sun's gravity alone, speculation went wild. Podcasts like The Joe Rogan Experience debated whether it could be a probe from another civilization. Twitter, Reddit, and TikTok filled with theories about an alien artifact passing silently through our cosmic neighborhood. But science, as always, speaks in evidence. And on that October morning, MeerKAT gave us a clue that no theory could ignore. According to the report, OH absorption was detected. At 1665 and 1667 megahertz, the same pattern seen in ordinary comets as they interact with solar radiation. This means that 3I Atlas, though interstellar, behaves like a comet born in another star system, an icy traveler carrying the chemical fingerprints of its homeworld. And yet, even as astronomers celebrated, others urged caution. Among them was Avi Loeb, the Harvard astrophysicist who famously suggested that Oumuamua might have been a fragment of alien technology. Loeb pointed out an eerie coincidence. The trajectory of 3I Atlas happens to align within just 9 degrees of the direction of the 1977 WOW signal, the mysterious radio burst detected by the Big Ear telescope in Ohio nearly 50 years ago. That proximity reignited questions. Could it be chance? Could the same region of the sky be home to something more? Perhaps an ancient beacon, or a relic drifting through interstellar space. Loeb had previously encouraged observatories like MeerKAT to search for radio emissions from 3I Atlas just in case. And they did. They found this OH absorption, but nothing else. No continuous signal, no modulated transmission, no beacon. Just the soft, natural hum of chemistry at work. Still, the search is far from over. Loeb and his team have already proposed a follow-up observation. In March 2026, 3I Atlas will pass within 53 million kilometers of Jupiter. That's close enough for NASA's Juno spacecraft HAL, orbiting Jupiter, to listen with its dipole antenna, scanning frequencies from 50 Hz to 40 MHz in hopes of catching even a whisper from the interstellar object. If anything unusual is there, even faint radio activity, Juno might be the first spacecraft to hear it. But let's step back for a moment. Think about what's happening here. For billions of years, fragments of other worlds have drifted between stars, silent and invisible. Only recently have we had the technology to detect them, and the imagination to ask where they came from. When Oumuamua passed through in 2017, it changed everything. For the first time, we realized our solar system wasn't isolated. It was part of a cosmic highway of interstellar debris. Then came Borisov, clearly a comet, streaming gas and dust. And now, 3I Atlas, carrying both mystery and familiarity, reminding us that even in the vastness between stars, nature follows the same rules. The MeerKAT detection is a breakthrough, not only because it confirms the cometary nature of 3I Atlas, but because it gives astronomers a chance to study an interstellar object at radio wavelengths for the very first time. These OH lines are like fingerprints, unique, unforgeable. They reveal how sunlight interacts with molecules, how radiation changes chemistry, how water, one of the key ingredients of life, behaves across light years of emptiness. And there's something deeply poetic about that, because every comet, no matter where it comes from, carries the same elements: hydrogen, oxygen, carbon, the building blocks of everything we are. When we detect those molecules, we're not just studying physics. We're looking at our own origins, reflected in a traveler from another star. But even as evidence piles up, mystery persists. Why did 3I Atlas fragment the way it did? Why did its trajectory shift slightly, echoing the strange motion of Oumuamua years before? Could there still be a mechanism we don't fully understand? Perhaps some form of outgassing or radiation-driven force we haven't yet modeled correctly. Astronomers are cautious. They know how easily excitement can blur the line between discovery and speculation, but they also know that every mystery, every anomaly, drives science forward. That's why the detection of a simple hydroxyl signal from an interstellar comet has captured so much attention. It bridges chemistry, astrophysics, and even philosophy. It reminds us how connected the universe really is, how something as small as a molecule can tell us where an object was born and how it evolved across unimaginable distances. As of now, 3I Atlas continues on its journey. In December, it will make its closest approach to Earth, giving astronomers another chance to study its composition, brightness, and motion in detail. Telescopes around the world, optical, infrared, and radio, are already scheduling observation windows. For many, this is a once-in-a-lifetime opportunity to study an interstellar visitor before it disappears back into the void. The discovery also sparks a wider question. How many more are out there? If 3 interstellar objects have been detected in just the past decade, could there be thousands, maybe millions, silently passing through our solar system every century, unseen, undetected, each carrying secrets from distant suns? As technology improves, especially with upcoming telescopes like the Vera Rubin Observatory and Square Kilometer Array, we'll likely detect more. And with each one, we'll learn more about the diversity of planetary systems across the galaxy, about how worlds form, break apart, and send their fragments across the stars. So, the signal from 3I Atlas wasn't a message from an alien civilization. It was something even more profound. A message from nature itself, written in chemistry and light. It reminds us that the universe doesn't need technology to speak to us. It's been speaking all along. We just needed to learn how to listen. And maybe that's the real story here. Not the speculation, not the conspiracies, not the clickbait headlines, but the quiet triumph of science, patiently peeling back the layers of mystery one discovery at a time. 3I. Atlas came from another star system, carrying the molecular whispers of its birthplace. It passed close enough for us to detect, to measure, to learn, and now it's leaving again, fading into the black, carrying with it the story of a moment when humanity looked up, listened, and heard the universe breathe.